dear students, in this video I am going to discuss about some JEE model problems from definite integrals. So definite integrals. This is one of the important chapter for competitive exams like MSET, mains, advanced, whatever it may be. It is a very most important chapter. Let us take one problem. Integral 1 to 5 x minus 1 into x minus 2 into x minus 3 into x minus 4 into x minus 5 dx. So evaluate this integral. So for evaluating this problem, generally we'll get one idea is taking the product of these 5 factors. We'll get one fifth degree polynomial. After that integrating, then applying the limits. That is one method, okay, but it is a laborious method. Don't go for that one. So in most important point in the definite integral is so many problems are obtained, solutions are obtained very easily by using the properties. That is the main use of the definite integrals. Most of the cases you can use the properties. So here by using property we can evaluate this one. We can go for the property. We know one property, integral a to b f of x dx is same as integral a to b f of a plus b minus x dx. These two integrals both are same. Integral a to b f of x dx is equals to integral a to b f of a plus b minus x dx. That means in the place of x you can write a plus b minus x, then the value of the integral is unaltered. So by using this property, let us take the solution. First we can assume that given integral is say I is equals to integral 1 to 5 x minus 1 into x minus 2 into x minus 3 into x minus 4 into x minus 5 dx. Now in the place of x we can write a plus b minus x. Here a value is 1, b value is 5. A plus b minus x means that is 1 plus 5 minus x, that is 6 minus x. So replace x by 6 minus x. Then what happened? Integral 1 to 5. Here replace x by, that means 6 minus x minus 1. So I'll get 5 minus x. Second factor becomes 6 minus x minus 2, 4 minus x, 3 minus x, 2 minus x, 1 minus x dx. So by observation, it is this integrand is there like a given integrand, but the difference is the minus sign. Here x minus 5 factor is there, here 5 minus 6. So that you have to take the minus sign common from all the factors. Totally here 5 factors are there, means we will get 5 minus signs. Finally we will get minus integral 1 to 5 x minus 1 into x minus 2 into x minus 3 into x minus 4 into x minus 5 dx. This is exactly our given integral I. So I equal to minus I, that implies 2I equals to 0. So what is the integral value? 0. So by using the property, directly we will get this answer. So this is a very important property. So many times in competitive exams the problems are given based on this property. Integral a to b f of x dx is same as integral a to b f of a plus b minus x dx. So one of the problem, it is based on that property. Next go for the second problem. So here integral minus 4 to minus 5 sine of x square minus 3 dx plus minus 2 to minus 1 sine of x square plus 12x plus 33 dx. So here sum of two integrals are given, and by observation both the limits are different. Here minus 4 to minus 5 or minus 2 to minus 1. And individually it is not possible to evaluate this integral because of sine of x square. Only sine x is there, okay, directly we know that is the elementary function, sine x integration, But here sine of x square minus 3 is there, directly we don't know. So what is the idea for evaluating this one? Such type of problems, compulsory we can make the one integral in terms of the other. That means in terms of the limits of the other by changing the or by using the substitution. Now by idea here in the second integral we can take the first integral as it is. Let us take the second integral. I2 is equals to, this is say I1. Let us take this is I2. What is I2? Minus 2 to minus 1 sine of. Here by observation in the first integral x square minus some constant is there. So here also you can make the square of some linear factor. That possibility is there here. X square plus 12x plus something means how to make the perfect square. It can be written as x plus 6 whole square. X plus 6 whole square. What is the remaining? X square plus 12x plus 36 is there. But actually 33 only is there. So minus 3. So we can simplify the second integral only. Now our aim is to make this integrand in the form of this one. So that by taking the substitution, put x plus 6 is equals to t. Then what are the limits? Actually x value is minus 2. Whenever if we take the substitution, compulsory we can change the limits also. When x equal to minus 2, what is the t value? 4. When x is equals to minus 2, t value is 4. And here when x is equal to minus 1, what is the t value? 5 sine of it will be t square minus 3 dt. Dx is equals to dt. Or this is okay, but here by observation here limits are minus 4 to minus 5 is there. Here 4 to 5. That the minus sign is different. That's why by idea we can take the substitution as x plus 6 is equals to minus t. X plus 6 is equals to minus t. Then we will get x value is minus 2 means it will be minus 4. X value is minus 1 means it will be minus 5 sine of t square minus 3 as it is, not change. And dx is equals to minus dt. So you will get a minus sign. So by observation exactly it is minus I1. That's why what is answer? First integral is I1, second integral is minus I1. Therefore required answer is 0. So this is also one of the idea. So by observation here, this integrand is the unknown function. It is not in the standard form. But sum of two integrals are given. In that case, we can evaluate one integral and converting in terms of the other. So this answer is 0. Next, third problem. Integral 1 by 2 to 2. Integral 1 by 2 to 2. 1 by x into sine of x minus 1 by x dx. So here by observation it is also one of the critical integrand. But compulsory we can use any one method. We can evaluate this one. So what is the observation here? Here limits are given 1 by 2 to 2. One is the reciprocal of the other. One limit is there, reciprocal of the other. In that case, we can take generally most of the cases we can take the substitution as variable x is equals to 1 by t or t is equals to 1 by x. So that for evaluating this problem, put x is equals to 1 by t and dx is equals to minus 1 by t square dt. Then I becomes lower limit is 2. When x equal to 1 by 2, t value 2. Upper limit becomes 1 by 2. What is the 1 by x value? T sine of 1 by t minus 1 by x value t and dx is minus 1 by t square dt. Or this will be 1 t gets cancelled. So here minus sign is there. Whenever interchanging the limits, we'll get minus sign. That is one property. Integral a to b f of x dx is same as minus integral b to a f of x dx. So for removing this negative sign, we can interchange the limits. So 1 by 2 to 2 and sine of 1 by t minus t into 1 by t dt. So after substitution, we'll get this integrand. Now by observation, we have to verify the given integrand. What is the given integrand? 1 by x. Here 1 by t is there. Sine of. So this angle is different with minus sign. Here x minus 1 by x is there. Here 1 by t minus t is there. That's why I have to take the minus common. Sine function is odd function. That's why sine of minus x is minus sine x. So that we'll get minus 1 by 2 to 2 sine of t minus 1 by t into 1 by t dt. So by observation, it is exactly our given integral I. So that minus I. That means 2i equals to 0. So I equals to 0. So that here the idea, I will get this idea based on the limits. If most of the cases, if one limit is the reciprocal of the other, in that case you have to take the substitution as variable x is equals to 1 by t. Next problem. Integral minus 2 to 2 sine square x by step of x by pi plus 1 by 2 dx. Integral minus 2 to 2 sine square x by, here step is given, step of x by pi plus 1 by 2 dx. So whenever the limits are given in the form of minus a to a, compulsory you have to verify the integrand nature, whether it is the even function or odd function. So here you know one property, integral minus a to a f of x dx. Integral minus a to f of x dx is equals to 2 times 0 to a f of x dx, when f of x is a even function. And this value is 0 when f of x is odd. Very, very useful property. So whenever we can use this property, limits, if the limits are given in the form of minus a to a, so that compulsory, in that case we have to verify the function. Sometimes the function is neither even nor odd cases also there. But here first, whatever it may be, we have to verify that integrand nature. So what is the even function definition? If the function f is said to be even function, means f of minus x is equals to f of x. Then that fx is called even. Odd function means f of minus x is equals to minus f of x. This is the definition of the odd function. So here we can take the integrand as some f of x. Let us take f of x is equals to sine square x by step of x by pi plus 1 by 2. This is the f of x. So to check the even or odd, immediately you can replace x by minus x. So f of minus x is equals to, here directly we'll get sine square x. In the place of x minus x, then also we'll get same. Here minus of step of x by pi plus 1 by 2. Now our aim is to make this function in terms of f of x. So here step of minus x by pi is there. We know one property, step of minus x is equals to minus 1 minus step x. Step of minus x is equals to minus 1 minus step x. So by using that property, this f of minus x as sine square x by minus 1 minus step of x by pi plus 1 by 2, or it can be written as sine square x by minus 1 by 2 minus step of x by pi. This is equals to minus of sine square x by 1 by 2 plus step of x by pi. So this is exactly minus of f of x. That means what is the nature of the f? F of x is an odd function. So the function f is odd, therefore what is the integral value? 0, by using that property. What is the property? Integral minus a to f of x dx value is 0 when f of x is odd. So this is one of the very important property. Whenever the limits are given in the form of minus a to a, compulsory have to verify the even and odd. Next, one more problem, similar problem. Integral minus pi by 2 to pi by 2 log of 2 minus sin theta by 2 plus sin theta d theta. Clearly it is, this one is also odd function. So that what is the answer? 0. So I will check this one is odd or even. Let us take given function is f of theta. F of theta is log of 2 minus sin theta by 2 plus sin theta. So what is f of minus theta? Log of 2, it will be plus sin theta by 2 minus sin theta. Or you can write reciprocal of this one. So you will get here minus sign. Minus log 2 minus sin theta by 2 plus sin theta. So that this is minus f of theta. That's why f of theta is an odd function. That's why integral value is 0. So that when the function is odd, directly you can write 0. In general, f of 2 minus x by 1 minus x by 1 plus x. Log of 1 minus x by 1 plus x is always an odd function. That's why that value is 0. Next one. If the function f of x is defined as f of x is equals to cos x minus integral 0 to x minus t into f of t dt, then f double dash of 0 plus f dash of 0 equals to. So here the idea is whenever the limits are given in terms of the variable, here lower limit is some constant but upper limit is the variable x is there. So in that case, most of the cases we can use the Leibniz theorem. So when the limits are given in the form of the variables, then immediately you have to differentiate the function. So the derivative of the definite integral means using the Leibniz theorem. What is the Leibniz formula? Integral phi 1 of x, lower limit is some function of x, upper limit is also some function of the variable x, phi 1 x2 phi 2 x f of t dt is equals to, how to apply that Leibniz formula? Just in the place of the variable t, I have to substituting the upper limit value f of phi 2 x into derivative of upper limit phi 2 dash. Next put the minus sign and substituting the lower limit in the place of t, f of phi 1 into its derivative. Fine. This is called the Leibniz rule. So whenever we can use the Leibniz rule, the integrand here, inside the integrand containing the single variable. Suppose here integrand containing x also, don't use this formula directly. So in that case, try to find the that variable outside. Try to we can take that x value outside. Otherwise, one more formula is there. So Leibniz one more formula, second formula, integral of phi 1 x to phi 2 of x f of x t dt. Here what is the nature of the integrand? Integrand containing the two variables x and t. In that case, what is the Leibniz formula? So in that case, directly Leibniz formula is applied. First we have to differentiate the partially with respect to x. After that, again we can use the first formula. So the formula is integral phi 1 of x into 2 phi 2 of x dou by dou x of f of x comma t dt plus the remaining part is same as the first formula. Just this term will get some extra into phi of f of phi 2 of x into phi 2 dash minus f of phi 1 of x into phi 1 dash. This is the formula for second formula for the Leibniz rule. So this second formula is applicable when we can use this formula when the integrand containing exactly x and t also. T is okay. X if x also there inside, then we can use. Most of the cases we can try to make the function in terms of t only by taking x terms outside. If that possibility is there, better than take that outside. Actually here what is the given function? F of x is equals to cos x minus integral 0 to x minus t into f of t dt. When substituting here x value directly, we will get 0. So don't put that x value. Or if applying the property integral a to b f of x dx property, then it becomes t, but again here we will get f of x minus t. Again we will get x terms here. So that in this case what is the idea? Either using the Leibniz second rule or try to converting the integrand completely in terms of x only. So that possibility is there here because of by separating two functions here, cos x minus integral 0 to x into f of t dt plus integral 0 to x t into f of t dt. This is cos x minus, here x is the constant because of here integration is there with respect to t. With respect to means you can treat as x is constant, take outside x into integral 0 to x f of t dt plus integral 0 to x t into f of t dt. So this is our given function. Now differentiate. F dash of x is equals to minus sin x. So here differentiate with respect to x means this is the function of x, this total is also will get a function of x. Because of when substituting the limit, final output is one function in terms of the variable x. That's why here we can treat as the uv form. So applying the product rule. What is the product rule? First function into derivative of second one, u into derivative of this one. Derivative of this one means we can use the Leibniz theorem. How to apply the limits in the case of Leibniz theorem? Just don't integrate in a function. Just in the place of variable, we can substituting the upper limit f of x into derivative of that upper limit. Derivative of x is 1 plus, actually here we will get plus but minus of is there, that's why minus second function into, here for lower limit what is the value? 0 because of already lower limit is constant. When differentiate that constant, second term becomes a 0. So second term becomes a 0. That's why when substituting 0, he'll get 0. Minus integral of 0 to x f of t dt into derivative of x is 1 plus here derivative of this function, here completely function of t is there. So replace t by x into f of x into derivative of upper limit 1, no need to write 1, minus for lower limit it becomes 0. So this is the function when differentiate, one time differentiate we will get f dash of x. So that by observation these two gets cancelled. This is the f dash of x, but here in the problem second derivative term is there. That's why again differentiate f double dash of x is equals to minus cos x. Here derivative of the definite integral means again using the Leibniz theorem, minus substituting x in the place of t, f of x into derivative of upper limit is 1, for lower limit value is 0. So this implies f double dash of x plus f of x is equals to minus cos x. This is one of the differential equation, but we want f double dash at 0, so that put x equals to 0, f double dash of 0 plus f of 0 equals to cos 0 value is minus 1. That is the answer for that problem. Next problem. F of x is equals to integral 2 to x 1 by root of 1 plus t power 4 dt, and g of x is the inverse of f of x, then g dash of 0. So we want g dash of 0. Here what is f of x? Integral 2 to x 1 by root of 1 plus t power 4 dt. Actually this integral is not possible to evaluate. This integrand directly not obtained. So by observation here upper limit x is there. That's why use the Leibniz theorem. Directly differentiate. What happened? F dash of x is equals to, using the Leibniz theorem means in the place of t we can substituting first upper limit. Then what happened? 1 by root of 1 plus x power 4 into derivative of the upper limit 1 minus substituting the lower limit and differentiate. Lower limit is constant. Whenever differentiate that constant we will get 0. So that directly we will get 0. So this is the f dash of x. Our aim is find the g dash of 0. And what is the connection between f of x and g of x? G of x is the inverse of f of x. G of x is the inverse of f of x. So here one function is inverse of other means their composite is x. From functions that property is there. So that we'll get g circle f of x is x, or g of f of x is x, or you can write f of g of x also x. Whatever it may be you can take. So this is the relation between g and f. The composite of g and f is x, because of one function is the inverse of the other. Now differentiate, because we want g dash of 0. So g dash of f of x differentiate into inner function derivative f dash of x is equals to 1. So here we will get one relation, g dash of f of x into f dash of x is equals to 1. But our aim is we have to find the g dash of 0. G dash of 0 is required. That means if for what value of f of x, in the place of f of x we want 0. So for what value of x this becomes 0, that is important. For what value of x it becomes 0. So by observation, f of x is equals to integral 2 to x 1 by root of 1 plus t power 4. What is the f of 2 value? F of 2 value means 2 to 2. F of 2 value 2 to 2. So here by observation, what is f of 2? Lower limit to upper limit 2 means 2 to 2 integrand. So what is the value? 0. Property integral a to a f of x dx value is 0. So that the functional value of f at 2 is 0. So that means the function is 0 at what value of x? 2. That's why by observation we have to substituting x value 2. Then what happened? G dash of f of 2. What is f of 2 value? 0. So 0 into f dash of x value is 2 means f dash of 2 equals to 1. So g dash of 0 into f dash of 2. Here already we know f dash of x. What is f dash of 2? It will be 16. 16 plus 1, 17. 1 by root 17 equals to 1. Therefore, g dash of 0 equals to root 17. So that is the g dash of 0. Suppose in this case, if it is not possible to find the g dash of x, g dash of something, in that case we can use the second relation. This one also true. When one function is inverse of the other means their composite function. What is the property? If f and f is one function and its inverse is f inverse, then f circle f inverse is equals to IA or F inverse circle F is equals to IB. These are the results. Identity function, so that G circle F of x equal to x, F circle G of x is also x. So here also, this is also the problem based on the Leibniz theorem. First I have to differentiate that function and take the relation. Next, go for the next one. I is equals to integral 1 to 2 dx by root of 2x cube minus 9x square minus 12x plus 4. Then some options are given here. Then I square value lies between 1 by 9 and 1 by 8. I square is lies between 1 by 3 and 1 by 2. Like options are given. So this is one of the problem based on the approximations. Here that range of that integral is given. So how to evaluate such type of problems? So in this case, you have to identify the maximum and minimum value of the integrand. Here, what is the given integral? Actually, this is a previous competitive problem. 2020 January in mains this problem is given. I is equals to 1 to 2 dx by root of 2x cube minus 9x square minus 12x plus 4. So let us take integrand as some f of x. F of x is equals to 1 by root of 2x cube minus 9x square minus 12x plus 4. Now we can identify, our aim is find the maximum and minimum values of this function. So for maximum or minimum, what is the process? First I have to find the derivative. F dash of x. F dash of x is it is in the form of 1 by, or it can be written as 2x cube minus 9x square minus 12x plus 4 whole power minus 1 by 2. So what is the derivative? Minus 1 by 2 into 2x cube minus 9x square minus 12x plus 4 whole power minus 3 by 2 into inner function derivative 6x square minus 18x minus 12. So for maximum or minimum, the necessary condition is f dash of x is equals to 0. So that actually this function is minus 6 common x square minus 3x minus 2 by denominator 2 into 2x cube minus 9x square minus 12x plus 4 whole power 3 by 2. So this is equals to 0. That means x square minus 3x minus 2 equals to 0. So x minus what is the here 6x square minus 18x minus 12, x square minus 2x, x square minus 2x plus 1. So here x square minus 3x minus 2 equals to 0. We are not getting factors. I think correction is there maybe in the problem. You can take here a plus symbol, then here plus, here plus, plus, here will get plus, plus. Now x square minus 3x plus 2 equals to 0. So x minus 1 into x minus 2 equals to 0. That means x is equals to 1 and 2. What are these points? These are the turning points or stationary points, or also known as the critical points. So actually here These are the limits also. In the problem, what are the limits? 1 to 2. Here obtained stationary points also same. So that compulsory at one point we'll get maximum value, at one point we'll get the minimum value. Sometimes we'll get stationary points lies in the given interval. In that case, I will get maximum value and minimum value. First we have to find the functional values at these critical points as well as at the given limits. After that we can identify the maximum value and the minimum value. So now we have to find the f of 1 value. F of 1 is 1 by root of 2 minus, I will get f of 1 from this, we will get f of 1. 2 minus 9 plus 12 plus 4. This is equals to 1 by under root 16, 18, 18 minus 9, 9. So 1 by 3. Next f of 2, 1 by root of 16 minus 36 plus 24 plus 4. Substituting in the given function, we will get f of 2. This is equals to 1 by under root 24, 16, 40. 40 minus 36, 4. 4 plus 4, 8. This is the 1 by 2 root. So that f of 1 value 1 by 3, f of 2 value 1 by 2 root. So by observation, this is the 2 root 2 means 2 point something, 2.8 something, 1.41 into 2, 2.8. This is 1 by 3. So this is the minimum value, it is the maximum. So once if you get minimum and maximum, what is the property? Integral a to b f of x dx. So for finding the maximum minimum value of the given integral, we can use this property. Integral a to b f of x dx. It's f of x minimum value is small m. Small m is the minimum and capital M is the maximum. Then the property is integral a to b f of x dx always lies between b minus a into m, small m, which is less than or equals to capital M into b minus a. So this is one of the property. When if you know maximum and minimum value of the integrand in the given interval, then m into b minus a is less than or equal to integral a to b f of x dx is less than or equal to m. I will get this one. Integral a to b f of x dx always lies between capital small m and capital M. Then f of x value lies between this one. Applying the integral with the limits a to b, then here we will get m into b minus a is less than or equal to integral a to b f of x dx is less than or equal to capital M into b minus a. This is the property. So that when we use this property here, what happened? Therefore, let us take I is the given integral. I is lies between b minus a. Here b minus a value is 2 minus 1. That means 1 into minimum value 1 by 3. So 1 by 3 is less than or equal to I. 1 by 3 is less than or equal to I, which is less than or equals to 1 by 2 root 2. Or squaring. I square is lies between 1 by 9 and 1 by 8. You can take here less than, strictly less than. So first option is correct. So this is one of the problem given in 2020 January main exam. Very simple problem. Just we can find the maximum and minimum value of the integrand. After getting the maximum and minimum, we can use this property. So What is that property? Integral a to b f of x dx is equals to m into b minus a, which is less than or equal to capital M into b minus a, where small m represents minimum value and capital M represents maximum value. So this is also one of the important model. Next, one more problem. Let capital M and small m are maximum and minimum value of the function f of x, where f of x is equals to minus 1 to x 1 plus mod s of t dt. Here given that x lies between 2 and 3, then step of capital M minus small m, maximum value minus minimum value, equals to how much? So this is also similar to one of the problems similar to the previous problem. First I have to find the maximum and minimum value of this total function. So for finding the maximum or minimum, what is the method? First I have to find the stationary points. So find the f dash of x. What is the given fx here? Integral minus 1 to x 1 plus modulus of t 1 plus mod t dt. So f dash of x. By observation here variable limits are given. That's why for finding the derivative you can use the Leibniz theorem. In the place of t, first you have to substituting the upper limit 1 plus mod x into derivative of upper limit, that is 1, minus substituting 1 here and derivative of lower limit, that value is 0. So that we will get 1 plus mod x. 1 plus mod x. And what are the given x values here? X values lie between 2 and 3. So by whatever it may be x, by observation 1 plus mod x is there. It is always positive quantity. 1 plus positive is always greater than 0. So that f dash of x is not equal to 0 here. F dash of x is greater than 0. That means you can say that f of x is the increasing function. Here f of x becomes increasing function. For all it is an increasing function, but you can take this interval because of condition is there on x. X lies between 2 to 3. So f is increasing in the interval 2 to 3. X lie between 2 and 3. So if one function is increasing function in the interval a comma b, then its minimum value is obtained at this point and maximum is obtained at this point, because of when if you take the graph, suppose it is an increasing function in the interval a comma b, then clearly minimum is obtained at the first value of x value and the maximum is obtained at b. Suppose when the function is decreasing, we will get reverse. That means here we will get minimum, here we will get maximum. Here the function is increasing. That's why what is the maximum value? So first we have to find the minimum value. So minimum small m, that is equals to f of 2. Now we have to, our aim is find the f of 2 value. What is f of 2? Here from this we will get f of 2. Integral minus 1 to 2 1 plus modulus of t dt. Then how to evaluate this integral? Don't substituting directly here integrating, because of your mod function is there. Whenever mod function is there, what is the method to evaluate the integrals? So try to remove that mod by splitting the interval at the stationary points or critical points. In the case of mod, what is the critical point? Mod t, what is the critical point? Means 0. So you can break the interval at 0. Minus 1 to 0 plus 0 to 2. Minus 1 to 0. Here these are the t values. T values lie between minus 1 to 0. Then what is the mod t from the definition? It becomes minus t. So it will be 1 minus t dt. 0 to 2. In 0 to 2 t is positive. So mod t becomes t dt. Now integrate. This is t minus t square by 2 limits minus 1 to 0 plus t plus t square by 2 limits 0 to 2. So for upper limit value is 0 minus, for lower limit minus 1 minus 1 by 2 plus 2 plus 4 by 2, that is 2. So you'll get minus 3 by 2. 3 by 2 plus 4, it will be 11 by 2. So this is the minimum value. Next, maximum value. What is the maximum? Maximum is equals to f of 3. So that is minus 1 to 2, 1 plus 1, 1 to 3. 1 to 3, 1 plus mod t dt. Same way you can splitting the interval, minus 1 to 0, next 0 to 3. Here 1 minus t dt, here 1 plus t dt. Already first integral value is there, as t is, what is that value? 3 by 2. Plus second integral value t plus t square by 2, limits 0 to 3. 3 by 2 plus 9, 3 plus 9 by 2. So that 3 by 2, here 9 by 2, 12 by 2, 6 plus 3, 9. This is the maximum. We want capital M minus small m step. That is 9 minus 11 by 2. So it will be 18. 18 minus 11, 7 by 2. So step of 3.5. What is the step of 3.53? So it is one of the integer type question. So that for evaluating this integral minus 1 to x 1 plus mod t, maximum and minimum values, just you have to differentiate the function. But an important point is mod. So whenever modulus of the functions are given, what is the working method? First you have to splitting the interval at the points where that integrand becomes 0. Those points are called the stationary points or critical points. Simply you can remember as the points where that integrand becomes 0. At those points only you have to split the intervals. For example, we can take one more problem based on the modulus, because of the integrand containing the modulus problems also very very important. So given that integral 0 to 2 pi modulus of cos x minus sin x dx. So here also integrand containing the modulus. So what is the working method? Whenever the integrand containing the modulus, then you have to splitting the interval where the integrand becomes 0. So how to identify that one means by putting the integrand value 0. Let us take cos x minus sin x is 0, or from this we'll get tan x is equals to 1. Then what are the x values? Actually infinitely many solutions are there, but no need to take all these solutions because here interval is there 0 to 2 pi. So at what values of x tan becomes 1 in the interval 0 to 2 pi, pi by 4, one of the stationary or critical point. Next tan is positive in third quadrant, pi plus pi by 4, that means 5 pi by 4. So only 2 points are applied. Then the idea is we can split the interval at these points. Therefore this I is equals to integral 0 to pi by 4 plus next pi by 4 to 5 pi by 4 plus 5 pi by 4 to 2 pi. So in 0 to pi by 4, what is the cos x minus sin x sign? So for removing the modulus, what is the idea? Immediately I have to check that inside function symbol. If it is positive, then directly drop the mod symbols. If it is negative, then you have to take the minus of that function. This is actually method. So in 0 to pi by 4, what is the cos x minus sin x symbol? Is it positive or negative? How to identify that one? So one way is by taking any angle in the given interval and verify the symbol. Suppose if you take the 30 degrees, cos 30, root 3 by 2 minus this value is 1 by 2, root 3 minus 1. So you will get clearly positive value. That's why cos x minus sin x positive means then modulus of cos x minus sin x becomes a cos x minus sin x positive quantity. Like that. Here once actually here two stationary points are there. In this interval this is positive means then compulsory in this interval it will be negative. So you will get sin x minus cos x. Negative means what is the modulus of that function? Minus of. Here positive again. Cos x minus sin x. These symbols alternatively you will get positive, negative like that. So first symbol is positive means here we will get negative, here positive. Now just integrating and substituting the values, you will get answer. Actually cos x integration is sin x plus sin integration minus cos plus cos x over the limits 0 to pi by 4. Here minus cos x minus sin x pi by 4 to pi by 4 plus cos sin x minus plus cos x 5 pi by 4 to 2 pi. So that after substituting we will get the answer. So that what is the idea? Whenever mod function is there, then how to evaluate that one? Immediately you have to break the interval at the points where that integrand is 0. So here two values are obtained. At these two values this function becomes 0. That's why you get a 3 integrals. Suppose here 3 points are obtained. Total you will get a 4 integrals. 0 to A to B, B to C, C to upper limit. So this is the method to find the mod functions when the function containing the mod. Next, integral 0 to n step x dx by integral 0 to n fraction of x dx. This is also one of the previous competitive exam question. In mains discussion, I will give you some what is the year I don't know exactly, but previous year problem. Integral 0 to n step x dx by integral 0 to n fraction of x dx. So first you can evaluate the numerator, integral 0 to n step x dx. What is the method to evaluate the integrand containing the step? Actually, whenever in the case of definite integrals, definite integral is possible when it must be continuous functions in the given interval. Here given interval is 0 to n, x lie between 0 to n. Integrand is step x is given. So step x is continuous where in the interval 0 to n it is not continuous. In the total interval that is not continuous. But in between two consecutive integers it is the continuous function. So that immediately you have to split the interval at the integers because of here step x is there. Whatever it may be, in the case of step functions, if the integrand involving the step functions, what is the method? We can break the interval at the points where that function becomes an integer. At what values of x the function is integer, immediately we can break the interval at those points. So here clearly x is there. X is integer means at 1, 2, 3 like that. That's why you have to break the intervals at integers. So 0 to 1, next 1 to 2, next to 2 to 3 like that. So last interval n minus 1 to n. Now we can identify this is constant actually. Always the graph lie between, the graph is parallel to the x-axis, always constant. In between 0 to 1, what is that constant? 0. When x lies between 0 to 1, step x value is 0, so it will be 0 dx. When x lies between 1 and 2, step x value is 1 dx, 2 dx. Finally we'll get n minus 1 dx. So this is 0. Here x, after applying the limits, we'll get 1 plus 2 into dx x limits 3 to 2 to 3 means 1 plus 3 into 1 so on. Last one is n minus 1 into 1. So 1 plus 2 plus 3 plus so on n minus 1. The sum of the first n minus 1 natural numbers. Sum of the first n natural numbers is n into n plus 1 by 2. Here n minus 1 into n plus 1, that will be n by 2. This is the, or simply it can be written as nc2. So that you can remember as a formula also, integral 0 to n step of x dx value direct nc2 or n into n minus 1 by 2. Like that we can find the integral 0 to n fraction of x dx. So one way is for evaluating this fraction of x, we can converting the fraction of x into step x. What is the fraction of x? Fraction of x is equals to x minus step x, and substituting, that is one way. Or here some other way also there. Fraction of x in algebraic functions, this function is one of the periodic function. Fraction of x is periodic function with the period 1. So one property is that integral 0 to nt f of x dx. If f is the periodic function with the period t, then integral 0 to nt f of x dx can be written as n times. We can take this integer outside. Integral n times integral 0 to t f of x dx. Like that integral 0 to n fraction of x. Here we can write 1. Fraction of x is the periodic function with the period is 1. That's why we can write this integral as n times 0 to 1 fraction of x dx. N times 0 to 1. Then x lies between 0 to 1 means that is x values takes the fraction only. So fraction of x becomes x. Whenever fraction of x is x, then x is exactly integer. So n times x square by 2. So limits 0 to 1, then we'll get n by 2. This is the denominator value. Then required is numerator is n into n minus 1 by 2, by denominator is n by 2. N by 2 gets cancelled, answer will be n minus 1. So this is also one of the important one. So that here in the case of integral 0 to n step of x dx, what is the direct formula? nc2. Suppose sometimes if you want integral 10 to 100 step of x dx, how to evaluate this one? Here no need to split the interval at the integer 10 to 11, 11 to like that, huge values are given. So in this case we can converting the interval into known form. What is the known formula? Integral 0 to n step of x dx equal to nc2. That's why this interval 10 to 100 can be written as 0 to 100 minus 0 to 10. So 0 to 100, from 0 you can take lower limit as 0, 0 to 100. From this interval you have to subtract 0 to 10. Then we will get 10 to 100. Then directly you can use the formula 0 to n, nc2, 100 c2, this is 10 c2. So this is one of the problem. Next one, integral tan inverse lambda to cot inverse lambda tan x by tan x plus cot x dx. So here by observation integrand is there in the form of f of x by. So here one property is there, integral a to b f of x by f of x plus f of a plus b minus x dx. So whenever integrand satisfies this condition, means f of x by f of x plus the second term is f of sum of the limits minus x. In that case direct answer b minus a by 2. This is one of the formula. I will get this one by using the, let us take this is I. Again you can take I as f of a plus b minus x by f of a plus b minus x plus fx, and adding these two, finally we will get this answer. So I'll get this idea by observation. A function, this is the function, by same function plus cot is there. Actually, what is f of a plus b minus x here? What is a plus b value? Cot inverse lambda plus tan inverse lambda. Cot inverse x plus tan inverse, that is pi by 2. So pi by 2 minus x, tan of pi by 2 minus x, that is cot x. So this condition satisfied. F of x by f of x plus f of tan of 90 minus x, it is satisfied. That's why what is the answer? So this answer directly b minus a by 2. B minus means cot inverse lambda minus tan inverse lambda by 2. So this is the actual answer. Or sometimes asking like this also, what is the range of this integral? What is the range of this definite integral? Range is required. So for finding that range, here given condition is lambda is any real number. Now I will get the range of cot inverse lambda minus tan inverse lambda by using the property. Cot inverse lambda means it can be written as pi by 2 minus tan inverse lambda minus tan inverse means here we will get 2 tan inverse. What is the range of tan inverse x? Tan inverse x always lies between minus pi by 2 to pi by 2, open interval minus pi by 2 to pi by 2. So that you will get range is obtained. One time you have to substituting minus pi by 2, other time pi by 2. So by whole by 2 also there. Then this is pi by 2. And if you write the plus pi by 2, what happened here? Pi by 2 minus pi by 2, one value. Next to pi by 2 plus 2 into that will be pi by 2. So minus pi by 4, and here 3 pi by 4, open interval minus pi by 4 to 3 pi. So the value of this definite integral must be lies in the interval minus pi by 4 to 3 pi by 4. So this is also one of the useful property. Integral a to b f of x by f of x plus f of a plus b minus x. You can remember this integrand nature, f of x by f of x plus f of a plus b minus x dx. Direct this value is b minus a by 2. So based on this property, 2 or 3 times in a mains examination, 2-3 times the problems are given. Or I can take one more problem. Suppose the integral 4 to 10 step of x square dx by step of x square minus 28x plus 196 the step of x square. So it can be written as integral 4 to 10 step of x square by step of x square plus actually it is the perfect square. It is a square of which one? This is 196. 14 minus x whole square. Step of 14 minus or x minus 14 whole square. Now by observation, it satisfies this condition. F of x, this is f of x by f of x plus this term will be f of a plus b minus x. What is f of a plus b minus x? A plus b is 14. 14 minus x whole square. Satisfied. That's why what is the answer direct? B minus a by 2. B minus a by 2. What is the b value? 10 minus a value 4 by 2. So this is equals to 6 by 2. That is a 3. So this answer is a 3. Next one more problem. The value of integral 0 to 1 x into cot inverse of 1 minus x square plus x power 4 dx. Actually, this is a problem is given in JEE Mains 2019 JEE Mains. Previous main question. Integral 0 to 1 x into cot inverse of 1 minus x square plus x power 4 dx. So the idea is here x into some other function is there. In that case, the idea is you can eliminate the x. So I will get how to eliminate the x here. By observation here 1 minus x square plus x power 4, even power terms are there. So that we can take the x square equal to as the substitution. Put x square equals to t. Then 2x dx is equals to dt. So x dx is equals to half dt. Then I is equals to integral. So whenever take the substitution, immediately you can change the limits also. Here given lower limit is x value 0. X value 0 means t value 0. And upper limit x value 1 means t value 1. So x dx becomes half dt. Take off outside dt. What is the remaining? Cot inverse of 1 minus x square t plus t square. Actually this one is also one of the problem. After take the substitution, we will get one new integrand. How to evaluate this integrand? It is one of the important model. So first we can make this function in terms of tan inverse. 1 by 2 integral 0 to 1 cot inverse x. Cot inverse x is same as tan inverse 1 by x. That means 1 by 1 minus t plus t square dt. So 0 to 1 tan inverse of. Here the idea is we can make this integrand in terms of known. In the case of tan inverse, we have two formulas are there. Tan inverse of x minus y by 1 plus xy, or tan inverse of x plus y by 1 minus xy. It will be tan inverse x minus tan inverse y. This is the tan inverse x plus tan inverse y. Based on some conditions also, different forms are there. So our aim is to make this function in terms of any one of the form. So which form is possible here? When if you take the minus t common here, 1 minus t into what are the factors t common, you will get the 1 minus t. So by observation this form is possible. 1 minus xy is there. So immediately what is required in numerator? X plus y. Actually what is the t plus 1 minus t? That will be 1. So replace directly 1 by 2 integral 0 to 1 tan inverse of t plus 1 minus t by 1 minus t into 1 minus t. So you will get 0 to 1 tan inverse x means tan inverse t plus integral 0 to 1 tan inverse 1 minus t. Next again one new integrand is applied. Integral of tan inverse t, by using the by parts we will get this integral. Here no need to find the tan inverse 1 minus t. Again we can apply the property. Integral 0 to a f of x dx is same as 0 to f of a minus x. Then the second integral becomes 0 to 1 tan inverse of t dt by using integral 0 to a f of x dx is equals to integral 0 to f of a minus x dx. By using this property, this integrand becomes tan inverse t. So here also same integral is there. Finally we will get 0 to 1 tan inverse t dt. So how to evaluate this one? Whenever inverse trigonometric functions are there, for evaluating that integral we can use the integration by parts. So here one function is there, I can treat other function as 1. This is the first, it is second. By using the by parts, we will get the integral value. It is also one of the important model. Actually, given integrand is x into cot inverse. After taking x square, we will get one new integrand. After applying the property, again some new integrals are obtained. It is the elementary function. For evaluating this integral, what is the method? We can use the integration by parts. Next, you can take one more problem. If lambda is equals to integral 0 to 1 dx by 1 plus x cube, and p is equals to limit n tends to infinity pi r values running from 1 to n cube plus r cube by n power 3n whole power 1 by n. Then log p. We have to find the log p in terms of lambda. So here by observation, pi is the given. Pi means product of the terms. Sigma means sum of the terms. So here one property is there. This is a problem based on the limit of the sum as the definite integral. So what is that property? Limit n tends to infinity 1 by n into f of r by n sigma, limit n tends to infinity 1 by n into sigma f of r by n. If any function is given like this, where r is equals to 1 to n, or r equal to 0 to n minus 1, or r equal to 0 to some pn, whatever it may be. So this summation value in terms of definite integral is integral in the place of r by n we can write x, f of x, and 1 by n becomes dx. This limit n tends to infinity, sigma becomes an integral sign. Limits are 0 to 1. So this is one of the relation between the definite integral and the limit of the sum. It is also one of the useful property. So that try to make this product into limit of the sum. Whenever if you want product into sum is nothing but sum of the terms. Pi is nothing but product of the terms. So whenever product of the terms becomes sum of the terms, we can apply log. So what is the log p value? Here log p is equals to limit n tends to infinity. Log of limit is same as limit of log of that function. So we will get 1 by n outside. And here so many terms are there, product of the terms. After applying the log, we will get a sum of the logs. Directly you can write sigma log of n cube plus r cube by n cube plus r cube by n power 3n, where r is equals to 1 to n. So when applying the log, this product of the terms becomes a sum of log of the terms, log of n cube plus r cube by that one. Now our aim is to make this summation in the desired form. What is the desired form? Limit n tends to infinity is required, is there, 1 by n is there. Here what is required? Inside we want function of r by n. Always the variable is r by n. In terms of r by n is required. So here we can did one mistake, I think. Maybe here after applying the log, what happened? Actually, what is the first term? N cube plus r cube by, we can write n cube. Next term is n cube plus 1 cube. Next n cube plus 2 cube by n cube. Next n cube plus 3 cube by n cube. So on. Last term is n cube plus n cube by n cube. So your denominator n cube into n cube into n cube into n cube, how many times will get n cube? N times. So that n cube whole power n. This is actually product, given product. Here n cube, when expanding this, we will get n cube plus 1 cube by n cube. Second term you can write n cube plus 2 cube by n cube. We can split this n power 3n as n cube into n cube into n cube into how many times? N times. After that, applying the log, what is the first term? Log of n cube plus 1 cube by n cube plus log of second term. That means here what is the denominator? N cube only. Log of n cube plus r cube by n cube. Now this is same as limit n tends to infinity 1 by n into sigma r equals to 1 to n log of splitting into terms n cube by n cube is 1 r by n whole cube. This is the desired form. Then by known property it can be written as everything is there, 1 by n is there, sigma as n tends to infinity, here function of r by n, under limits 0 to 1 log of 1 plus x cube dx. This is the log p value. But our aim is we can find the log p in terms of the lambda. Here evaluate this integral. So only one function is there and containing log. In that case also we can use the integration by parts by taking the other function as a 1. So this is the first function, it is the second function. And applying the integration by parts, what is the formula? First function into log of 1 plus x cube, first function into integral of second, integral of 1 dx, that is x, minus integral 0 to 1 derivative of first one, 1 by 1 plus x cube into 3x square into integral of second one is x dx. Here limits 0 to 1. And substituting the upper limit we will get log 2, for lower limit it will be 0, minus, so this is 3 times integral 0 to 1 x cube by 1 plus x cube dx, log 2 minus 3 times 0 to 1. How to evaluate this integral? X cube by 1 plus x cube. So what is the idea? Immediately here add and subtract 1. 1 plus x cube minus 1 by 1 plus x cube dx. This equals to log 2 minus 3 into splitting into 2 integrals 0 to 1 1 dx minus 0 to 1 1 by 1 plus x cube dx. So that log 2 minus 3 into 1 dx is x, after applying the limit we will get 1 plus 3 times, this is the given this integral value is given as lambda, so that in the place of this one we can write lambda, 3 lambda. This is the required. So this is also one of the important concept. Infinite limit is given means immediately we can recall that. So it is a problem based on the limit of this sum. So the conversion is important. Whenever limit of this sum is given, immediately we can converting that function into required form. What is the required form? Limit n tends to infinity, 1 by n is required compulsory, 1 by n into sigma r equals to 1 to n, f of r by n, function of r by n is required. Then immediately you can write 0 to 1 f of x dx. Sometimes here r equal to 1 to pn will be given. In that case the limits becomes 0 to p. Here multiple of some multiple of n is given means that multiple becomes upper limit. So here there is no p, that's why you will get a 1. Next integral 0 to pi by 4 2 secant x whole power, actually 2019 is given, here we can take out 2020, whatever it may be power. Similar problem is given in advanced exam. So here given that 2 secant x whole power 2020 dx. For evaluating this one, Actually the options are given in terms of again one integral, so I have to converting this integral in terms of other integral based on the options. Here no need to take options. So for evaluating this one, we can take this identity. We know that secant x plus tan x is equals to t. Then what is secant x minus tan x? One is the reciprocal of the other, so it will be 1 by t. So here secant x, adding these two, we'll get 2 secant x is equals to t plus 1 by t. So directly in the place of 2 secant x, we can write t plus 1 by t. Next, what is the dx value? I will get dx. So differentiate this one, we will get the dx. What is the derivative of secant x? Secant x tan x plus tan x derivative secant square x of dx is equals to 1. That means dt. Or secant x common, secant x plus tan x dx is equals to dt. So secant, now we can converting this function in terms of t. Dx equals to dt by what is secant x? 1 by 2 into t plus 1 by t, and secant x plus tan x is t dt. Now put all these values here. Then I is equals to changing the limits. For lower limit, secant 0 1, tan 0 0, so 1, secant pi by 4 root 2 plus tan pi by 4 1, so it will be root 2 plus 1. What is 2 secant x? T plus 1 by t whole power 20 20, and dx is dt by 1 by 2 into t plus 1 by t into t. So here by 2 is means 2 times integral 1 to root 2 plus 1. T plus 1 by t gets cancelled. Then what is the power? T plus 1 by t whole power 2090 into 1 by t dt. This is the required answer. So this is a previous advanced question. It is also actually previous advanced question is here cosecant x is given. Suppose here cosecant x is given, what is the idea? Then immediately you can take the identity in terms of cosecant and cot. What is that one? Cosecant x plus cot x is equals to t. Then cosecant x minus cot x becomes 1 by t. So we can make that function in terms of t. Next one, limit m tends to infinity, integral 0 to infinity dx by 1 plus x square plus x power 4 so on x power 2m is equals to a by b. Then what is the value of a plus b? So by observation here one series is there, and also m tends to infinity means this denominator is the infinite series. By observation it is the gp, because of common ratio is same, x square x square x square, so that's why. So you can use the infinite gp formula, integral 0 to infinity. What is the infinite gp formula? So a by 1 minus r, if r value is less than 1, sum to infinite gp value is a by 1 minus r when r value is less than 1. That's why here what are the x values? X values lies between 0 to infinity. In that case don't write that formula, because of here x square is the common ratio. That common ratio must be less than 1, then only we can use this formula. So that what is the idea? Immediately we can split the interval at 1. Integral 0 to 1 dx by 1 plus x square plus x power 4 so on to x power 2m plus 1 to infinity dx by 1 plus x square plus x power 4 so on. M tends to infinity. So that here first integral can be written as dx by a value 1 by 1 minus r is x square, integral 0 to 1, plus as common ratio value is greater than 1. Actually what is the general form of the gp? A plus ar square so on. If infinite GB is given, what is the formula? This is A by 1 minus R. The condition is modulus of R is less than 1. If R value is greater than 1, then these terms are increasing order. So when adding the values, we'll get a Hughes value. Hughes value means we can treat as the infinity. So that when a common ratio is greater than 1, then what is the sum to infinite GP value? Infinity. That means it becomes 1 to infinity dx by this denominator becomes infinity. So something by infinity means it will be 0. So this second integral vanish. What about first integral? 1 minus x square integral 0 to 1 dx a by 1 minus r. So x minus x cube by 3. Limits 0 to 1. 1 minus 1 by 3. For lower limit value is 0. So 2 by 3. So this is the value of a by b. Then what is the a plus b? Here x square a by 1 minus r, where r value x square. It is okay. Take in numerator 1 minus x square, x minus x cube by 3, 0 to 1, 1 minus 1 by 3. That's why 2 by 3. Therefore, a plus b equals to 2 plus 3, that is the 5. Next one. Let a belongs to 0 comma pi by 2, then the value of limit a tending to 0, 1 by a cube into integral 0 to a ln of 1 plus tan a into tan x dx. So this is actually given problem. As a tending to 0 means we will get 0 by 0 form, okay, because of as a tending to 0, 0 to 0. So this value is 0 by a cube is 0. Then immediately we will get one idea is 0 by 0 form means immediately I have to apply the L'Hospital rule. That is one way, but I think that is it may be laborious process. Log of 1 plus tan a into tan x. 1 plus tan a into tan. So that we can is better to apply the Leibniz theorem, because of by observation it will be 0 by 0. Because of I will get 0 by 0 as a tending to 0 means limits becomes 0 to 0. So that this value is 0. By a cube is there 0, 0 by 0 form. So in that case we can apply the L'Hospital rule. L'Hospital LH rule. What is the LH rule? We have to differentiate numerator and denominator separately. What is the derivative of numerator? This is the numerator, it is the denominator. What is the derivative of numerator? 0 to a means you have to differentiate with respect to a. It will be log of ln is nothing but log ln of 1 plus tan a into tan a, tan square a by, that is the numerator. Derivative of this one means using the Leibniz theorem. In the place of x we can write a 1 plus tan square a into a derivative 1. For lower limit value is 0 by derivative of denominator 3a square. This is one of the limits. Standard formula is there. As x tending to 0, log of 1 plus x by x, this value is 1. Or log of 1 plus ax by x, this value is a. So here what is required actually? By same variable is required. 1 plus tan square a is there means here tan square a is required. So that it will be a tending to 0 log of 1 plus tan square a by tan square a into tan square a by 3a square. So limit of this value is 1. Limit of this value tan square a by a square is 1. 1 by 3. So answer will be 1 by 3. Next one. integral 0 to 1 pi r equal to 1 to n x plus r into sigma k equals to 1 to n 1 by x plus k dx. So for evaluating this problem here, pi is product of the terms, sigma means sum of the terms. Actually it is a very simple problem. Once if you know substitution, then it will be very simple. So here we can take pi r is equals to 1 to n x plus r is equals to some t. Take one substitution, put the product of the terms equals to t. Applying log on both sides, whenever the product of the terms are given, when applying the log, then we will get the sum of the terms, sum of the logs, sigma log of x plus r ln of x plus r equals to 1 to n is equals to log t. Now differentiate logarithmic function derivative 1 by x. So we will get the 1 by x plus r, sigma r equals to 1 to n 1 by x plus r dx is equals to 1 by t dt. So that once if I take this product is t, then this summation, total summation terms is equals to 1 by t dt. Then what is the given integral I? Given integral I is equals to we have to converting the limits also. For lower limit x value is 0, so it will be product of r equal to 1, next to 1 into 2 into 3 into so on, n is obtained. That will be n factorial. When x equal to 0, we will get n factorial. For upper limit, what is r value? 1. X value is 1 first, 1 plus r. After that, put the r values 1 plus 1, next 1 plus 2. That means first term is 2, 2 into 3 into 4 into so on. Last term is 1 plus n, n plus 1. So 2, 3, 4 so on, n plus 1. First term 1 you can multiplying with 1, no problem. 1 into 2 into so on, up to n plus 1 terms are there. Product of first n plus 1 natural numbers will be n plus 1 factorial. This is the upper limit. And this total becomes 1 by t dt. And pi of sigma r equal to 1 to n x plus r becomes t. These two gets cancelled. We will get dt. Integral of dt is t. After applying the limits, we will get n plus 1 factorial minus n factorial. This n plus 1 factorial can be written as n factorial into n plus 1 minus n factorial. So n factorial common. So n plus 1 into 1. 1 gets cancelled. So n into n factorial is the answer. Next one. If a greater than 0, integral 0 to infinity e power minus ax into sin bx by x dx. So this is one of the different problem. 0 to infinity e power minus ax into sin bx by x dx. So a is some constant here, a is greater than 0. Then by observation, finally we will get answer in terms of b. That means we can treat as this is a function of b. Function of b, or function of a b also, or function of b. 0 to infinity e power minus ax into sin bx by x dx. Directly by known method it is not possible to evaluate this integral. This is one different model. So the answer is the function of b. That's why we can take the I of b. Now differentiate with respect to b. I dash of b is equals to integral 0 to infinity. So here important point is differentiate with respect to b. Then I dash of b equal 0 to infinity. E power minus ax is constant. With respect to b means x is constant. A is already constant. And by x is also constant. What is the derivative of sin bx when b is the variable? We will get cos bx into x is the constant into x dx. These two gets cancelled. So this is one of the direct formula. This value is a by a square plus b square. So I have to similar formulas are there. Integral 0 to infinity e power minus ax cos bx value is a by a square plus b square, condition a greater than 0. Like that, integral 0 to infinity e power minus ax into sin bx is equals to b by a square plus b square. Remember these two formulas. So by using the definite integral, first we can evaluate that integral. After that, substituting the limits, we'll get this one. This is the I dash of b. We want I of b, integral value. So I will get I of b integrating. I of b is equals to integral a by a square plus b square db. Integration with respect to b. So a constant. It is in the form of 1 by a square plus x square. 1 by a into tan inverse x by a, b by a plus some integrating constant c. A cancel. So tan inverse b by a plus c. Where c is the integrating constant. I will get integrating constant. Some initial condition is required, but here directly not given that condition. If you want c value, we can use here find the I of 0. What is the I of 0? Put b value is 0. Put b value is 0. What happens? Sin 0 0. Everything becomes 0. So I of 0 value is 0. So for finding the integrating constant, we can use that constant, that condition. Put b equal to 0. Then I of 0 is 0. Tan inverse 0 is 0. C. That means c value is 0. So finally, what is I of b? Tan inverse b by a. So this is one of the different. It is also, we can use a different model problem, this one. So here, what is the idea? Here integrand contains some unknowns, not the numerical values. Some unknowns are there. In that case, better to differentiate first with respect to that unknown. Similarly, we can do this problem also. I of a is equals to integral 0 to 1 x power cos a minus 1 by log x dx. Same concept. So here a is the some constant. What is the idea? The output must be, we'll get in terms of a. That's why I of a. So directly evaluating this integral, it is not possible. In that case, we have to differentiate first with respect to a. With respect to a means log x constant, x is constant, then it will be a power x form. Differentiate, we'll get I dash of a. After that, again integrating, we'll get I of a. So you can do yourself. This is also on the same concept, problem based on the same concept. Next one, integral a to b modulus of sin x dx equal to 8. Integral 0 to a plus b mod cos x dx equals 9. Then what are the values of a and b? So here we know one property, integral 0 to pi mod sin x dx. This value is 2 units. By finding the area or whatever it may be, integral 0 to pi mod sin x dx is 2 units. But here given that this integral value is 8 units, then what is the idea? Like that, integral 0 to pi cos x dx, this is also 2 units, or integral 0 to pi by 2 cos x dx becomes 1 unit. This value is 1. So these are the some values. Like that, some based on the periodic properties, integral a to a plus nt f of x dx. When f of x is the periodic function with the period t, then a to a plus nt can be written as n times 0 to t f of x dx. This is the one of the property based on the periodic function. When f is a periodic function with the period t, then integral a to a plus nt f of x dx is equals to n times 0 to t f of x dx. So that first we can make this integrand as a to a plus nt form. So here we can write a to a plus b minus a mod sin x dx is equals to 8. Suppose if b minus a value 4 pi, what is a mod sin x? Mod sin x is the periodic function with the period pi. Suppose if b minus a value 4 pi, then we will get this value is 8, because if b minus a is 4 pi, what happened? A to a plus 4 pi mod sin x dx. So mod sin x is periodic function with the period pi, then these limits can be written as 4 times 0 to pi mod sin